Okay, so our goal is now, like I said, figure out abstractions for doing these problems. Now that we have an idea of, why we are doing this and the kind of problems we have, and we've seen that for the pink thing, threads, IPC, bounded buffer, they've been the abstractions we've been using. You use them in the exam, you use them in your assignments. In IPC, we've seen NIO and RMI. There's many kinds of IPC mechanisms possible. So the question is, what kind of abstractions can we have? And abstraction means we are sort of abstracting out the essence. And if we can abstract out to the ultimate, we would have complete automation. That you would just say, here's my program, distribute it or speed it up. And you're laughing. But I've actually, does anybody remember, we've talked about this before. For the pink side, have we talked about some case that can be made distributed without writing any distribution-aware code? We talked about this, but you probably don't remember because we kind of did it cursively. That we just take a program that's written and it becomes distributed. We talked about the RMI server, that what if the registry is running at a well-defined location? There's only one registry in the world. So this is unintuitive, but this was actually done in Xerox. Okay. So what they did was they had a system with already existing program with a bunch of modules. Think of modules as static classes with static methods. Okay, that can be dynamically loaded. So the dynamically loader went to a well-known registry, said, does somebody know where the location is? And if there was none, if there was no well-known location, it went and loaded it on that same computer. Otherwise, it went and connected to that particular computer. Okay, the one that the registry gave answered with. So the underlying infrastructure was distribution aware, but your programs, they were never distribution aware, except that you had to go and just run them and register them from a particular location, which was done outside the programs. So they really.
So if the computer is already running the module, you could just use it.
You could use some other computer's module. Because you went to the registry and said, I want this module. Do you know of a location? It said here. And then you just made your RMI calls there. Okay? So that's a very restricted kind of program. We don't have choice about, yeah.
Isn't this how like zombie distributed programming works? Where you have multiple computers that are unintentionally running the programs for you?
So is zombie
yeah, it's like a type of virus. Is someone accidentally downloads a virus and then it uses part of their processing speed to do something.
Oh, okay. You can always say any virus involves you writing a program that is unaware of what the virus wants to do. Yeah. Absolutely. That was not, I don't think that's a bug or a feature. I don't know. So this is what happened. Loader contacts registry to determine if local module loaded or remote module accessed. And you just have one namespace, one instance of each servers, cannot handle replication. This is very restricted, but it's possible. Okay? And similar, so motivates RPC transparency, where we say that, we'll make some parts transparent and some parts aware. That's what you guys have been doing. That's the more reasonable thing. But like I said, this was the ultimate, and there was a system called Cedar at Xerox that was built this way. Similarly, there's all this legacy code, especially in Fortran. And there's been a lot of work in trying to automate that completely. And Cook at Illinois and Kennedy at Rice have been doing most of this work. And by the way, Cook's son is an Olympic speed skater medalist. And I said it already. I was going to ask you guys, what do you think he is, a figure skater or a speed skater? And given that, that Cook himself was interested in speed, this guy also is into speed. So the physical speed was computer speed. So, but what are the constraints here? How far can you go here? Are there any theoretical constraints you can imagine? Yeah.
I mean, eventually you're not going to be able to parallelize things further. You're going to get to what I would essentially consider like an atomic processing.
So you're saying that, the granularity of parallelism is limited.
Yeah.
Can you parallelize any program? Really? I mean, you have to kind of know what the program is doing, right?
So it depends. I think postfix, multiplication, addition, you can parallelize a significant it down to like a specific operation, it doesn't mean anything to do on the set of computers. So I don't know if the phrase for that would be like atomic processing, but that's,
No, so you're saying granularity is an issue.
yeah.
Any other issue? It's kind of related. Availability, let's assume that we have the computers, yeah.
I think parallelization can make something slower. If the amount of time that you gain from sending it to another
Okay.
computer.
So you might do it wrong.
Propagation delay.
You might do it wrong. You might increase the time.
Yeah.
Could you do it wrong? Could you end up doing something that doesn't preserve the original semantics? Huh?
Yeah, that's
Why?
because you don't understand how the original program works.
You don't. So we're talking of some program improving another program. Okay, some parallelizing compiler improving another program, and you're saying that parallelizing program may not understand what the parallelized program does. Are there any limits to understanding other programs?
Yeah.
It's,
What is the limit? Sorry?
it's basically the halting problem.
Halting problem. Okay? We can't even tell whether another program halts, which means we can't tell if two programs are equivalent, which means you can't say a lot of things. Okay, so there's limits to how much we can do. And that will bring in limits of granularity also. Okay? So what we want to do is not do complete automation, but make automation easier for classes of problems. Okay, there are certain problems you can do easier than others, and that's our goal. So I'm using the word declarative abstraction. Okay, so anybody, have you guys seen declarative term before in any course?
Function declarations,
Function declarations. What else do you declare in a program?
variables,
Variables. But have you heard of declarative versus something programming?
event,
Okay. So, I thought I had a slide. Okay, we'll just get to that. Okay, let me just finish these slides. So we're going to do something called declarative abstractions. We don't quite know what they are, but they are high-level abstractions. Think of that. Okay, and okay, here we go. So, can you, from the English word, figure out declarative versus imperative? I use imperative here. Yes.
So declarative, you don't have to understand the underneath mechanics to achieve the goal you want to do. You just declare what you want. So like declarative language, like HTML.
Okay. Good. You-
Imperative is like you have to know what you're doing.
You have to know. What does the word imperative sentence mean in English?
Compels you.
Sorry?
Compels you.
It tells you something. Imperative means you're giving steps. You're ordering the computer. Do this, do this, do this. Micromanagement there. Whereas in declarative, you're saying what you want. Yeah.
So could it be something like Java versus let's say Python, where you don't have different times, you just have one time and the computer decides it for you?
So yes, you're right that so let's just take Java itself. Okay. In Java, the variable declaration, I would go and say, so it's not Java versus Python, it is certain details of these two languages. So we say type declaration, we're just saying what we want, okay? And we have a function declaration, so I didn't like the function declaration too much. Yes, you're declaring functions, but in the function you're giving all the steps, right? So that's imperative, okay? So declarative specify what we want. So, the system could go and allocate these numbers, pack these numbers together in memory, or it could spread it out. Okay, you don't have a choice there. And by the way, which one do you think it does when you have an array?
I mean, arrays are usually continuous.
Okay, and why are they laid out continuously?
Because they're fixed. You cannot add to an array which is fixed to them.
It's iterative memory access. That's why your arrays are continuous.
Yeah, you can do iterative access when they spread out too. But if you spread out, you have to figure out how spread out it is, right?
Spreads.
It's faster to index because if you load one chunk, then
Faster because if you load one chunk, it all gets loaded together.
Yeah.
And what's the term for it, the technical term for it that you might have studied in architecture or somewhere? What kind of feature are you exploiting in programs? locality. Okay, locality is going to be very important in this whole parallel algorithms thing. Okay, so that's why I mentioned this.
Plus, if you spread it out, then it's basically just a linked list at that point.
You can think of it that way. Okay, so locality relevant to PDC abstraction later. So this is the thing. And imperative, we implement what we want. Okay? And they could be procedural languages, they could be functional languages, they could be OO languages. So sometimes they talk of declarative as a procedural. That's also fine. But the word procedural is overloaded. It's also used to distinguish Pascal-like languages and C-like languages from object-oriented languages and Lisp-like languages. So that's why I'm using imperative rather than declarative, than procedure. Okay, but typically, a lot of times they'll say declarative versus procedure.
So do you mean, are you going to call C an imperative language?
Yeah, of course, because you say what you want. In C, you have to say more than in Java. At least Java will handle the garbage collection for you.
Instead of it being Java, Python, it's Java C.
No, it's not Java. Java and Python are both imperative
Right, so instead of Java, Python, it's Java C.
to some degree.
What-
To some degree,
so what-
because the garbage collection part you're leaving unspecified. So it depends on what aspect you're talking about, right? So
What is an example of a declarative?
what's the example of declarative language? So let's come to that.
Oh,
So how many of you done 455? Which one of this is declarative? I've got two things here. Which one is declarative? Which one is procedural? They're both declarative. They're both procedural. Regular expression is declarative. Finite state automata is, if you come to this step, if you see this thing, do this. Right? So that's an example of something you've seen already. And we will see more of this in the parallel computing thing.
So I guess the thing that I'm kind of confused here is I feel like you could easily switch between a regular expression and like a DFA.
Okay, so that's the other thing. Okay, so by the way, these state machines are going to be important. In a two-phase commit, you have to keep track of stakes. Am I in the accept stage? Am I in the proposal make stage? So state machines are very important in distributed programming. Okay, so ease of programming. Would you rather write a regular expression or write an automata?
Why do we have projects?
And they're both equal. Okay, and so ease of programming is, I'm not going to get into that. Okay, if you've written regular expressions, trying to debug them is not easy. And there are tools available on the web to do it. And we've got regular expressions in the grader, and so I won't get into that part. But so we have to make sure that when we add declarative constructs to our language, we can convince ourselves that they really are easier to program, because just because they're declarative doesn't mean they're easier to program. Okay? How many of you have done Prolog? Yeah. So Prolog is declarative, and I'm not going to say it's easy to program, okay? Because you might be just used to more procedural thinking or imperative thinking. Okay. So what we'd like to do is, why am I mentioning declarative? Because we would like to add some declarative concepts, if possible, that are easy to use for our PDC stuff, okay? And that means PDC means both concurrency and distribution. So rather than having, saying create a new thread, start a thread, okay? And again, you should love it because you got into trouble with the start method. We're going to just say somehow abstractly we want a thread. Okay? None of this stuff. Instead of saying rebind and look up, we're going to use some higher level abstractions. That's the goal. Okay? We don't know what these are right now, but that's the goal. And again, since we're doing, whenever you do high level, whether we do declarative or procedural, high level means we are trying to relieve you from some steps. Whenever we relieve you from some steps, we make decisions for you. That means you're going to lose some flexibility. So we're going to do it for restricted classes of programs. This is not going to be a solution for everything. So let's start with concurrency. Okay? And we really want declarative stuff that is arguably easier to program. So let's take a concrete problem here. We're going to do simple problems. We're not going to do the grader in here. So I want to output two random numbers. Okay? the output of a random number I'm going to do procedure in an imperative fashion. Okay? But I want to, in a declarative fashion, create two threads to print these two numbers. To create the two numbers simultaneously and print them. Okay? So this part we're going to use Java for. But it's concurrency part that we don't want to use. We don't want to use thread.start and create a runnable and do something that's closer to the problem. So invent something. What do you want to tell the computer here? If you could just, it has to know that you want two threads. So I want you to tell me what the macro should be. What is this? What comes to your mind as sort of the most direct way to say what you want?
Something like run.command with the command, comma, the number of threads you want the command to be run by, comma, do you want them to be run at the same time or one after the other?
So for this problem, we do want it to run at the same time, right? So let's not give too many parameters. So we want to go and say number of threads and the fact that we want the two threads to execute in, each thread to execute this.
This just sounds like a high-level method.
Right. And we are going to, so tell me the syntax of your method.
Like, is fine.
That method takes as an argument the statement. Do methods take as argument statements in Java?
I mean, you can convert it to a string and then give it to.
So you're getting into problems here. Can convert it, can do this. Have you ever done it? You can compile code. You can in Java, by the way. You haven't done it, but I have done it. You can take code and compile it and run it. Okay, but so it's not a method. Okay, and don't get too caught up in whether it's method or statement. We're trying to figure out, what is the most concise way of saying this. And he's already said what the kind of things you want. So we're going to put a comment on top. Okay, and we're going to use the word OMP because this is OpenMP. And we're going to say, I want this done parallel, and how many threads should go and execute it. Okay? Direct, you like it? We have better than thread.start and thread.run?
I'd rather just read the manual, how to do it, and then...
You had read the manual and gotten into these problems.
The manual needs to explicitly show me the example.
Okay. So, you guys get the idea of what we're doing here? Okay? And this is real stuff. This is not something I invented.
It's a comment,
It's a comment.
and a comment affects the program.
Somehow.
There's the preprocessor.
Okay, so that I was going to get into next. So I want to keep Java, and yet I want to have the cake and eat it too. So I want to keep Java, and yet I want this facility. And so this is a declarative concurrency specification called a PRAGMA or a directive in OpenMP. Okay? And OpenMP, the word open typically means it's not tied to something. So it's not like RMI tied to Java. Okay? So it's tied to, so the implementation of it exists in the languages that are known to be efficient. Okay? Firstly, or legacy languages. So Fortran, how many of you have actually heard of Fortran? Oh, all of you have heard of it. Anybody used
We all
Fortran?
heard it from you.
Okay. I was a EE major. That was my first language. You have done? Okay. So, Fortran was used for numeric computation. Okay? And numeric computations are the ones that we want to fasten. So, there's a lot of legacy code in Fortran. And so, Fortran, and you can see how the syntax changes of the comments. Okay, or in one case it's a macro, in the other case it's a comment. But the basic idea is that we annotate text. Okay, and so I use the word annotation. In Java we have annotations, right? What do you annotate in Java? What kind of constructs do you annotate? So what are we? Override is an annotation associated with what kind of construct? What do you override? A method. And annotation can be put on function declaration, on method declarations, and also on variable declarations. But you can't annotate statements. Okay? So even, lot of stuff that's been done for Java and other languages haven't made use of annotations. But you can think of them as annotations for statements. That's what I said, that a method can't take a statement as an argument. Okay, it can take a lambda expression as an argument, which is a separate thing.
I know you can override symbols in Java. Can we annotate overrides of symbols in Java?
Can you
Annotate overrides of symbols in Java.
annotate overrides of symbols? What do you mean by that?
Like, I know at least in C that you can override a symbol, like,
Oh, no, you can't. You can't define your own plus.
I can't define in Java.
No, you can't. In C++ you can, in Java you can't. Okay? And that would have been nice for parallel computing, by the way, because we want to use a defined plus sometimes. Okay? So that's not override. You learnt in 401. Is override, and what is the other term that begins with over? Anybody else?
Overload.
Overload. Okay, that's overloading plus. That's not overriding plus. Okay, and you don't want to override plus, because if plus becomes minus, things can get very confusing. And that's kind of why Java did not go that way. That they don't want the pluses, because if you allow overloading, you'll also allow overriding. And Java didn't want to go that way and allow these problems to occur. Okay. So so what you do is, there's always in OMP there's an attributed statement, and you are annotating the attributed statement. Okay. So then the question becomes, how did that comment get processed? Okay. That's what Andrew said, that you write a source program in some language that could be concurrency unaware or aware. Java is concurrency aware language, but you could begin with a language like Fortran, which is totally concurrency unaware, and you add to it a new language essentially. Okay, and that's this new language. It could have declarative constructs. It could also have procedural constructs, and in fact, OpenMP has both, and we're going to look at both. Okay. And now we have a pre-compiler that goes and processes just the extra stuff and converts that into a source program in the original language. Okay? And that is processed by a native language compiler, which creates a compiled program. And in Java, what happens with the compiled program? Is that processed by some other program further? Interpreter. Okay? So that happens in Java. It doesn't happen in C or Fortran. So that's the structure. That's what's happening underneath. We're just defining special kinds of comments.
Is Java one pass or two pass?
Compiler?
Yeah.
So do you have to have the method declarations? Do you have to use a method before declaring it?
Sometimes, sure, I can.
Do you mean you to declare?
So actually it's a one-pass compiler, but things are put in the symbol table, and you do allow things to get out of, you can use the method, you can before you declare it.
So how do you
That's
do
this.
that? Because then the function won't with the symbol table yet.
So the pass is what? The parser and the lexical scanner are one pass. After that, you use the symbol table. So there's two pass. But in some languages, you have to declare them in the same order.
Yeah. See,
In C, you have to do that?
Yeah,
you have to declare like a function header.
even if you override the function header later.
Yeah. And even in one pass, what you can just say is that I defer the thing. That I've put some value here, and later I will fill that up. That's what I believe Java does. And that's how it connects to linking also, and loading also. So it is going to do one pass over the syntax tree, but just fill in the values later. Okay? So just to make this all real, I didn't mention that there, but Java is not one of the languages supported by OpenMP. Okay? But there's an undergrad at Prague who built something called OMP4J, undergrad in his thesis, which is very credible. And I found that code, and that code kind of works and kind of implements OpenMP. So I'll show you examples where it worked. And when examples where I don't show you output, it didn't work. Okay, but it's still a very nice piece of code. And actually found a bug there, and I reported to those guys and his advisor. And he said, "Can you fix it?" And I have other things to do. So, so you say something like this: OMP4J minus S. Minus S means don't do all the steps at one stage. So what it does is converts random.java into another random.java, which has got all the comments expanded out. And then you can go and say Java C random.java because your random.java has been replaced. And then you can do Java random. Okay? Okay, questions?
And you can see what it's doing, right? After
You can see what it's been doing.
okay.
Yeah. In fact, in your Gypsy code, I've added examples.openmp, MP, this thing here, and I've got you the pre-code and the post-code both.
Oh, okay.
So I went in, it took a long while because his compiler just replaces the file. So I've got the original file and the replaced file, and you can actually see what happened.
Do we have OpenMP in any of our assignments?
Sorry?
Do we have OpenMP in any of our assignments? Are we using this in any?
No, your assignments don't use OpenMP, but your extra-credit assignment requires you to implement something like OpenMP and MapReduce. Okay, so that you get to understand what this happened at an implementation level. So it's our own 533 version of it. No, I would not recommend using this for anything. Just because, can you see a problem here? Your random.java, you've converted it into another file and then you have to debug it.
If you want to use the original one, you can.
And your debugger is looking at, showing you stuff that you never wrote. And then you want to change the original code, and then the other code has to be changed.
So is there a way to, instead of having it overwrite random.java, have it write to a different file?
I couldn't find a way. So I had to always go and copy and paste.
That's frustrating.
I couldn't find a single flag that did it. Yeah, they
Overwrite the OMP4J macro and have it save.
yeah, it's a program, and it's in Git, so maybe someday I'll fix it. Okay? Actually, I've got a better idea. I don't want to use a precompiler approach. I want to use a proxy approach. But just as you know, we have proxies that you make a method call in one process, it goes to another process. How about a proxy call that you make and it magically creates threads and forwards actions to the threads? So that's what I'm thinking actually as a way to solve this problem, if I want to ever do this seriously.
If you proxy PDs though, why not just wrap this in a different language and do this in C?
You can always use C. You're welcome to use C.
But like for the thing you talked about, instead of proxying to another version.
So the deal is this, that OpenMP, and I've been running out of time, is really meant to be used for people. The whole idea there is that, you know how you guys study data structures, algorithms, and so forth, and then you have a course on parallel and distributed computing, where everything has to come together, right? Why not have every course have a parallel component in it, including Conf 110? When you learn bubble sort, you learn also parallel bubble sort, okay? And that's the goal of certain. So when I went to this conference, I learned that this was a big deal for them. So why not use C? Because you might have been taught a course in Java. And there are good reasons to teach things in Java. I was going by some undergrads yesterday, and one person was saying, I love Java because it scolds you when you make a mistake, whereas Python doesn't do that. So there are reasons why you want to do that. Okay, so we're running out of time, and we've understood the structure here. Next time we're going to go and we'll review a little bit, and we're going to look at the actual fancier directives than just parallel. Okay? This was the point that I had made earlier, that we take this particular function, we want this executed multiple times or multiple threads, so we put this pragma in there, this comment in Java, that says I want 2 threads to execute this particular statement, and I want each of these threads to execute the statement, right? And at that point, Richard said, why do we need this? Why can't we just have a method call here? Okay, and I pointed out, okay, guys, you two need to, Chris and Richard, you need to focus here. Okay, but and especially when I'm talking about your issue. So I went and said, hey, can you really pass a statement to a method call? Okay, so Richard is not one to give up. And he said, let's go and put this statement in some quotes and let's go and have it compiled at runtime. And is that something you can do in Java? Not in every language. You can't in every language at runtime just compile the program and link it dynamically. But in Java, there's a dynamic loader. Okay, so you can do that. But the unit of compilation is, if it's a statement, then somehow your existing program has to be able to name that statement and say, go and call that statement. And statements are not named. So if I'm going to go and compile a piece of text and have that piece of text compiled code executed from my program, which was not aware of that statement, has to somehow call that, has to somehow invoke that statement, right? And if it doesn't have a name, I can't go and just call it. Okay? So what do you think the unit of compilation in Java? A class. Okay, you can't, so you'll have to put that in a method, and you will have to put that in a class, and you can do that then. Okay, so statements cannot be individually compiled. So your parallel method can encapsulate statement in a method and class. And if it's going to encapsulate that in a method and class, what interface do you think this class is going to implement when we are trying to do this particular task? Okay, it's going to implement runnable because we want to have a thread executed. Okay, so now let me just create some problems. Can you see some problems still? Having to do with scoping. So every statement has a scope. It can look at variables and access variables in its scope. When I put that statement in a separate class and method, can you imagine some problems occurring?
You have to physically consider where you want to create the class and how are you going to construct the class.
So the class you can create as an inner class within the class that was, or you can create as external class. Okay, and Andrew, you had some.
Yeah, except those would be lambdas and Java. So it's basically for that basically so that you are a lower scope than whatever is around you, but you can only access things that are effectively final, which basically means you don't change them anywhere. Because otherwise, you end up with consistency issues. This is running parallel to something else. You change it halfway here, change it halfway over there.
Okay, so there are concurrency issues. Okay, by the way, before we go there, is this a good idea if you could do this before we go to scope? So what if your string had some errors? Okay, you're going to get these errors at runtime. You're trying to do high performance computing and you're compiling at runtime, okay, which takes time. So there's the compilation cost. Okay, now let me go back to the scope issues. So there's always the synchronization, these concurrency issues, but let's consider variables in the statement. A statement can be a block. The variables in the statement that are variables accessed in the statement that are not declared in the statement and are also not global. Okay, so I've got this particular piece of code here. What I've parallelized is something within something within braces. That I've put these braces here so that to show that we could declare variables inside this. And I'm actually accessing a variable called non-statement, non-global, which is declared outside my statement, but it's not inside the class. It's not an instance variable or a global variable, okay, or a static variable. If it's a global variable, an inner class can handle that. Okay, an inner class can go and access the global variables, but an inner class cannot access such a variable. Okay, so with lambda expressions, you impose conditions on what can happen. Here we would not like to impose such conditions. Yeah.
So how does OMP handle this interface?
Okay, so that's a good question. Well, how do you think it should? What do you think we can do? We are replacing the statement. So clearly we need, so OMP can kind of handle, because OMP is a precompiler. It can go and find these variables. Your method call couldn't even look at that stuff. So the method call idea is just going away, even though I like it very much, because precompilation has all kinds of issues. Okay? So we're going to have to abandon that idea. and go for the declarative compilation concept, because that particular precompiler can look at the full context and do something with it. Now the question is, even if when it sees this particular statement before that, when it sees this particular variable and knows it's declared outside, what should it do? What do you guys, we're going to create a class. We have to create a runnable underneath. So what can we do at this point?
To accomplish what exactly?
To be able to access a variable such as this. Yeah.
First thing I thought of was to create like a command class, and then in that class you could have that variable you pass it when you construct it.
Very good. So we've done that, we've seen that with command classes, that we can at construction time go and create copies of pass the value in the constructor. Okay? And then that is what we do before we enter the statement. At the end of the statement, what do?
We get all the variables we passed back as like some sort of a return value, and if you can't wrap them into a single enum or something to return, then you have to call it using, I guess, Java is always reference, so everything just has to be returned, I guess.
So let's be very clear. There was some variable such as this one, whose value had to be passed to this particular class. Now, in C, you can pass variables by reference, but in Java, only object variables have references. So a non-object variable such as int creates more problems, and that is why we need to go and copy its value. So we need to send its value in a constructor argument or using some other mechanism like public variables, and copy it to an internal variable in that class. And at the end of this particular statement, when the run method is executed and we have finished doing it, there's no function call at that time. Okay, so we need to extract that value out. And how do we extract values out of objects?
Getters.
A getter, or if it's a public variable, just get it out. Okay? So you get the basic idea. I'll show you the exact steps later and the exact code also later.
So in this case, since we're working in Java, it needs to be put into a class or we run parallel twice. And anonymous class can already access things from the higher scope. So
The anonymous inner class can only access instance variables and class variables. It can't access a variable like this. Okay? That's why I said it's a long name. Non-statement, non-global. Okay?
So I would assume that it would have to call the getters inside the second nest, because the moment it goes outside the second nest, that class becomes invalidated or destructive.
So say that again, I didn't get what you said.
So taking a more, since Java has a garbage collector, taking more of a C analogy here, in the second nest, before,
Second nest meaning?
as in the second brackets, second set of brackets,
Right.
before actually getting out of the bracket, we'd have to call the getters to put the variables back.
We are going to replace this piece of code with another piece of code. And this particular piece of code is going to be embedded in a method in a class. Remember that?
Yeah.
In a runnable.
Yeah, I got that. So I'm saying that.
And we are going to execute the.
So I'm saying that before we go out of scope of that class itself, we would have to call the getters.
We are going to go and pass to that. We're going to create a thread, and we're going to have to wait for the thread to finish.
So
The
that's
creator.
my question. If we wait for the thread to finish, doesn't the threads class itself get destructed, and how will it get the variables using the getters once it has been destructed?
A class will not get destroyed. Okay, class just stays. You're talking about the object.
Yeah,
As long as you have a reference to the object will stay too.
I see. Okay.
Isn't
Okay.
this more of a problem with Java rather than just having two threads that are trying to access a certain spot?
So what is a thread? A thread is an independent stack. And the bottom of the stack is the start procedure of that thread.
Because in this case, do we have 5 or 3 threads here?
So we started with a thread.
So let's say that the beginning is like, this is all running in a main thread.
Okay, thread 0.
So is the first OMP parallel thread node, is that actually coming before this this first set of brackets? So are we essentially creating 4 threads here?
Did I say 3? We're creating 2 threads, plus the one we had already.
The thing on the top is not part of our example. The very, very top.
Right, sorry. Yeah.
Just to make sure. Okay.
Yeah.
So
Yeah.
why wouldn't,
That is from the previous thing, yeah. Good. Yeah, that's, the top one is not a part of the example.
Oh, that's what I was saying, next.
Yeah.
I thought that offer was
Yeah, no, I didn't even see the top one. Yeah. Okay?
couldn't you just communicate the change in the variable just through memory?
It is done through memory.
Right,
Okay, I'll clarify this with exact steps in code, okay? It is done through memory, but you said this is a Java problem. A thread is basically a new stack. You need a new procedure at the bottom of the stack. In Java, that happens to be called the run method. Okay? In pthreads, it will be another a procedure you pass to the pthread call. So you do need to go through a process like this, where you have to create a new stack from an existing stack. Okay, so it's not quite just a Java problem. Java is just the concrete language I'm showing to. Okay. So we need a compiler approach, and this stuff is propagating. So I'll try to remember to remove that top box. So attributed statement block encapsulated a runnable method in class. Okay. And so statement run method. So we don't execute the statement, we execute the run method in a separate thread, just as I said. Thread num times. Okay, so we have a for loop that will go and create num threads. And the parent thread will wait for the threads to finish. Okay, but it will have a reference to that object. Okay, you should have attended yesterday's talk. There was a lot of discussion of this kind of stuff in that talk, and how the garbage space, the heap space of various threads are managed actually.
Yeah, I wanted to add on.
Executes the next statement after that, after waiting, okay, and creates another context class. You can do what you talked about, that pass the variables to that particular class itself, but we do want multiple threads to be able to share that variable value. Okay, so we create a separate class with a separate object and pass references to this object to all the threads. Okay, actually in OpenMP you have a choice. You can go one way or the other. So by default, it's the way their implementation works is that it creates a separate context class. Okay, but you could create local copies, or you could create a one copy. Okay, but the point is you want to take these variables that were non-global and make them global to this particular class, to a particular class, so that they can be accessed by the runnable class. Okay, and before the run method executed, these global variables are assigned to corresponding instance variables, and after run method, you go and copy them back. Okay, and here's the code. So we have. This is the original statement. Okay, that original statement is accessing a variable, and so this is the original statement, and OMP context is the context we created, the shared context we created that can be accessed by all the threads. Okay, this is the class in which this particular statement got encapsulated, and we are not doing thread.start. Okay, we are making the start happen through another object called the OMP executor, which is going to actually call the start thread. It's the start. Can you imagine why I'm doing this indirectly? Why am I not just starting the thread? Why am I making some other object start the thread? The same object starts all threads.
You can keep track of all the threads.
So that, why do we need to keep track of all the threads? You have to wait. You have to wait for them to finish. Okay, so you create this particular object, okay, and then you wait for it to finish. Okay, and then here's and we're going to create as many threads as our loops tells us. Okay, so in this case it happens to be 2, and This is the variable that that is being shared in this particular statement. So we go and put this in the OMP context, and this is the class OMP context, and we could use getters or setters, but this class is not visible to anybody else, so we don't have to worry about encapsulation. So we just go and make it a public variable, and you see here that before the loop, the public variable is being assigned this particular variable, and you see at the end it's being copied back.
Would the IF's back be 1 or 2?
So you're talking of concurrency problems?
Yeah.
We'll deal with that a little later. Okay? Yeah.
So here it was a simple plus plus statement, and so you could do OMP context or local something plus plus. But if it was not a plus plus statement, let's say it was an assignment or if it was
Yeah.
something
Whatever that was, wherever there was non-statement global,
Yeah.
it gets replaced by OMP context.local. So every occurrence of that, the precompiler replaces with this.
No,
So if this could be 1,000 lines, and every line where these variables were referenced get replaced.
yeah, so my question is, what if it was not something to do with the variable, what if it was just a print line? So it would do OMP context or print line?
No, I'm just saying you take the original code,
Yeah,
do a global substitution of each of these variables with this,
I see.
and if there is nothing to substitute, there's nothing to substitute.
So why bother doing a variable replacement with the OMP context, or why not put it in a method and call the method? Why not put it in a method inside OMP context?
Put what it in the method? What is the it you got to put in the method?
So what if I create a method inside class OMP context? Let's say public void x, and inside public void x I do local non-statement global plus plus, and then here instead of doing OMP context dot.
Okay, so let's be very clear. I have one class that is going to be the runnable. That is going to execute.
Yes.
So in the run method, I have to go and put the original code. Here, the context is just the global state. It is not the runnable. So before you go to these solutions, what's wrong with the solution? Because I don't know what the solution is. So first find me a problem here.
So what my intuition here is that what is wrong here is that if I have, as you said, 1,000 variables, I would have to replace all 1,000 variables with OMP context or all 1,000 variable references, and that is incredibly inefficient in my according to me,
Why is it inefficient?
because I'm replacing 1,000 things.
That's done at pre-compile time, at compilation time.
It's still taking time.
But it's not done at runtime. Okay? And what you're saying is that you also want some form of indirection.
Yes.
So why don't you think about that indirection? And what you're saying is make a method call here, which is also going to cost you at runtime. So there's no way about it. The fact is that I cannot access this variable directly, the original variable directly.
Yeah.
I have to go and do something else instead of that. So every reference to the original global variable has to be changed in some way. Whether you make a method call to do it, which is going to be a runtime cost, or you do something like this, which is a compile time cost, you be the judge.
I see. Yeah. Because my intuition was that a runtime cost would be cheaper than 1,000 compile time cost, but I see the thing is runtime versus.
No, but even if there were 1,000 references to this particular statement, you'd have to make 1,000 changes there also, because you have to go and replace each of these with a method call.
The OMP context class still can't directly access the non-statement non-global variable. You have to, you have to put this whole thing on top, and just put all of this inside, put your version inside of this again. Because it's non-statement non-global, the new class can't access it.
The point is the new class cannot access this variable, so you have to do something with that particular reference. There's no way about it. And think about it offline, see whether you can come up with a solution. Okay? Yeah.
So is this whole block from the first bracket to the end bracket replacing what we were trying to do before?
Yes.
So we're not going to need the pragma at all when we're using this.
This is what precompiler did with the
This is
pragma.
what it does?
Yeah.
Okay.
And it removes the pragma. Okay? Questions?
So, is it non-local, non-statement, non-global is eventually it is a variable in the parent thread that calls.
No, that was, I don't want to go back because I'll lose my recording. But that was a variable that was not declared in the statement that we are parallelizing. That's why it's a non-statement variable. It was not an instance variable or a class variable. So it's not a global. It's something in between that the inner class cannot see directly. Because it cannot see directly, I have to go and have the inner class access something else that it can see that has the same value.
So it's like that variable is in the scope of
Yes, when we go and convert this into a class, it's not in the scope of that class. Exactly. Okay. Okay. Any other questions? Hunter?
I'm just barely grasping it as we go. Yeah.
So you get the basic idea that we have to. There are variables that are not in our scope.
I understand that we, in the bottom right there, OMP context, local, non-state, non-global. I know we did that because we needed like Jed said earlier, command object that stores.
Let's not think command object. We are not really executing the command. The runnable is a command object. It's an idea similar to command object where we used to go and pass values in the constructor. It's not quite a command object. The whole idea is that I've put this code in an independent class. That class cannot see these variables.
The point being is that you can pass primitive variables as an object of reference memory.
So the idea is that we should be able to access those variables, those values.
Yes. Okay.
So since we can't access them directly, we'll just copy the values. We'll create another set of variables that have the value at the start and whose values are then copied back. So we're just going to take those variables and put them in another object while the threads are executing. And when the threads finish, we'll copy these values back to the scope from which we created the thread. Okay, so there's a scope that creates the thread. There's a thread scope itself.
Well, the part creating the threads is right there, right?
Right, it's right there. So this particular piece of code can see that variable. It's just that this particular piece of code can't see it.
Right, I get it. The point being that has a reference to it in
Yeah.
memory.
And if these were not primitive variables, we could just pass the references.
Right.
Because we have primitive variables, we have to do this copy.
So if threads are sharing space and memory, why not just pass the pointer to the memory of the variable to the thread so that they can edit them?
So that's the point.
less
That's the point I just made. That it's a primitive variable. There are no references to the primitive variables. And if you're doing big data computation, you probably have a lot of primitive. You want to have a lot of primitive values. So yesterday's talk was making a big deal of the fact that when you have objects that have to be garbage collected, you have to do a lot of object creation and garbage collection when you go and create integers and floats. And integers and floats also are not mutable. So even if you had a reference, if it was not a mutable object, you can't do anything about it. Okay, so because we are working with primitive values, we have to make a copy. If you're working in C, it would have been much easier.
Yeah, that's what I was thinking. Like, isn't this much easier in C?
There's a lot of thises. So this particular part is easier in C.
Yeah, Java bytecode doesn't have any instructions for referencing privileges with addresses.
So, like, one of the things I'm familiar with in, like, SQL query planners is composing primitive data types into larger structures. For example, like a vectorized table could hold all the primitives in your big data set in a smaller format than you could if you had all the primitives separately. So why don't we pass a vector, or like a data structural form of our primitive?
Yeah, I just answered that question. So you can always go and send an object rather than a primitive value, and that object will take space, and you should go and watch this faculty recruiting talk yesterday. And it talked about even if you're doing large data processing, the cost of allocating those data structures from heap and then garbage collecting them is just humongous.
But is it faster or slower than this?
It's much slower. I just said the cost is very high. Garbage collection can get to be a real problem.
Well, garbage collection would be post all of this, so.
Sorry?
So garbage collection would be after we would do these executions on these.
No, they'll be done while you're executing the for loop. While you're executing the for loop, it'll be done. Okay? And the point is you'll just run out of memory. And again, this solution is really meant to be a solution for all, that covers all languages and all kinds of programming expertise. And the students who are going to go and have to allocate objects would have to know far more than those who are just assigning values. Okay? So again, it's the usual case versus the unusual case. Okay, more questions?
I'm sorry, did you say there will be garbage collection during the fall?
Yeah, because if you there will be garbage collection in the for loop. If you don't access something after a while, if there's no reference, you remove it. Again, I strongly recommend you watch yesterday's talk.
So what if you have like some sort of lock on that non-statement?
Yeah, that was the same question that Sam also asked. Let's get to that.
Yeah, there's different levels of garbage collection. There's the study access recently or not as recently, and then free memory. So it'll be moving from recent to the access to unrecently accessed in the middle.
And actually, yesterday's talk talked about yet another form of garbage collection, which is you start it, you take the loop and you say start garbage collection phase and end garbage collection phase, and that memory is allocated separately. So there's many things possible. Anyway, I want to pop up a level. So what I just showed you was that we can take this OpenMP abstraction of parallelizing a block of code and simulate that using Java's existing abstractions of runnable and classes. Okay. So what I've done is I've shown you how some abstraction can be implemented using another abstraction. So have you guys seen this in other classes? Implement one abstraction or another abstraction and see whether you can do so or not? Where, Hunter?
I mean, this is a weird way to say it, but abstractly, yes, I've seen that. I'm imagining like using another object as an element of creating some bigger abstraction that is,
Yeah, but some well-known abstraction. Yeah, sure. We can always try to simulate.
Example, and I know I've done that. Yeah.
So this has to do with expressibility of abstractions. How expressible are they? Have you guys seen? A lot of you have seen this expressibility in. In 455? No? Can you convert a regular expression into finite state automata? Can you do the reverse? Right? Can you convert a push automata to a finite state automata?
Yeah.
A push automata is a finite state automata with a stack. So you can go one way and not the other. In operating systems, can you implement monitors using semaphores? Did you guys see that in operating systems? Those of you who did operating systems? No? No?
Why did you call this expressibility?
Sorry?
Why did you call this expressibility?
Because what range of concurrency algorithms can I express using one abstraction or the other? What kind of computations can I do using this versus that? So that's the expressibility. How expressive was the computation? So we talk of low-level and high-level abstractions. Low levels are more expressive, but they typically require more work. High level are typically less expressive. Okay, so you guys didn't do semaphores versus monitors in operating systems. Okay, you can go both ways. My favorite question here is to implement a semaphore using monitors. It's a very simple solution, but people have a lot of trouble in final exams with this kind of question. And you can try to answer the same question in IPC: RMI plus threads versus NIO plus threads. Can you simulate one with the other? That will be a long process to derive that, but the answer is yes. Okay. So what we are doing here, so this is a general idea of expressibility, that how expressive is an abstraction. So far we've been using OpenMP. We've seen how much simpler it is, and we'll put simpler in quotes. But also we've seen that, and it's not going to be as expressive. Okay. So the other considerations: performance. Okay, you might lose some performance when you go to another abstraction, and ease of programming, which is the level. That how easy it is to program the abstraction, even though it can express a range of requirements. It can support a range of requirements. So, and here we don't go into proofs. Here we use experimental data or make arguments. So I can probably argue that writing that piece of code, again, Gatti, that's the part that got replaced. So that box got replaced with this. And you can probably argue that that one is easier to write. Okay? But I'm always wary of making this argument. Like I said, we don't know whether regular expressions are easier or just writing the code yourself is easier, because regular expressions cause a lot of problems if you just look at Stack Overflow anytime. Okay? You can't debug them as you can debug your own code. Okay? So, but I'll take Gatti's example to sort of argue why OpenMP is better. And Gatti is somebody who just made his problems public, but I'm sure you guys also had similar problems. So he was trying to figure out how to create threads. And I said, you've done operating systems, so how did you do it in operating systems? They said, oh, I used fork. Now, fork is actually used for process creation and not thread creation. But, you know, process threads, we've seen in operating system, we've seen in this class, they're both schedulable entities. It's easy to confuse. So then the next step he went was to look up the Java API, went to Stack Overflow, found examples of thread creation. It took some time, and then his code wasn't working. And he made the same mistake that half of you guys made in the exam of calling run rather than start. And in the exam, it cost you 1 point. In his case, it cost him a whole day, probably. A week. Okay? So we can argue that going from pthreads and C to Java was a big deal for him. And that's because he was using these imperative concepts. And you can argue, we haven't done a study here, then going from here to here is a much easier task. Okay? So let's go and still print the random numbers, but use this trace method that also prints the current thread. So we'll be able to print the actual thread that was created by OpenMP and verify that what I said really happens or not. Okay? So it's going to print not only what we want to print, but also the thread that was active in the statement was called. Okay? That's my trace method, which is like the trace method you guys have used in your assignments. Okay? And what I would expect is this, right? That you print the thread, you print, 2 different threads get printed before each random number. Are we guaranteed to get this output? What else can happen?
You can have just have a mix, mixed up.
Mixed
So
up?
You get both threads output before both numbers.
You've seen in the exam that can happen, right? So I had to run it 2 or 3 times before I got this. Okay, but this is an actual output, right? So you've all seen this. And if I was to, what is the Java solution to this problem? If I was not using OpenMP, what should I do here to make sure that I get them not mixed up? Okay. So I do something like this. Can I do a little better than this? In terms of high level, in terms of programmability?
I can pass synchronized or asynchronized as a parameter to OMP.
And what about this?
I can just create, I can just do it on.
So no, but okay, I mean, so what do we really want to happen? If I go and pass synchronized as a parameter to this, that means this whole piece, this whole block gets serialized. What is the point of doing parallel? So if I'm going to pass synchronized to OpenMP, I should annotate what? What you want to be synchronized. Okay, not the whole thing. And the problem with this is, and the solution with this, the problem with the solution is that you needed this. What if this is in a static method? This piece of code. There is no this. We are talking about using this idea in C and other Fortran, which are non-object oriented. Okay, so we need to just go and remove this and have an implicit object that OpenMP knows about, that on which we synchronize. Okay, so that's the OpenMP solution. So trace may be called in a static method. So we'll have code like this. Okay, so we say OMP critical. We just say it's a critical region. Okay, and the fact which object is used to go and guarantee which excludes exclusion is up to the system. Okay, so that takes straight, all the questions about synchronization you guys were asking, gets taken care of.
So if you more than one line, you just put it inside a
Block.
Yeah.
Block.
Could you declare the critical region when you go to, when you're in, like, inside the trace method?
No, as Nijjar said, this can be a block. And before the block, you put OMP critical. And to say that this particular piece of code should be executed atomically.
But what I'm saying is that, could you remove that and put it in your trace?
Oh, in the trace itself. Yes.
And would you get the same result, or would it?
It'll do something, the synchronized this can be done that way, right? This critical is being implemented with synchronized with its common object. So it'll given how it's going to be implemented, yes, you get the same result.
Because if you put it inside the trace method, then it wouldn't have knowledge about that's being called from a separate parallel section. So it would make basically you can only have OMP critical inside OMP parallel section in the first place, I believe. But you'd only be serious with each call of trace, not between independent calls.
As long as there's a unique object, okay, let's say we synchronize on OMP context or the executor.
Yeah,
It doesn't matter where you call it.
Inside the method, because the method itself, if you put inside the method itself doesn't know to take your context. So it would have to modify the signature for your trace method in order to do that.
Well, the precompiler can just do it, right? The precompiler is doing this, remember?
I mean, I bring this up because there's a certain point in having certain parts of a method be the critical sections, not the entire method being the critical section.
Sure. Yeah, so that's why it's not associated with just a method, it's associated with a statement. But it should work either way, okay, because it's just using a common object. As long as that object is visible at that point, it will work either way. Yeah.
In this particular example, because this is all we're doing, like this trace method, if we synchronize it, is it the load run faster than a single thread? Because it's still
Oh, so that's good.
so
All we're doing is this and it's become a critical section. So it's not a very good use. Okay, I'm going to get to that. The examples are small and one-liners, so I can fit them in a slide. But then you run into this problem that why did we go and serialize this whole thing? Okay. So the idea was to motivate, and as Gatti said, typically it will be some part of a method that you're not critical. Okay. So we've got now, we've got a critical section idea there. Okay, let's make this a little bit more realistic. So, right now, the complete program is parallelized. Okay, our program is just print random, and the whole thing is parallelized. Okay, typically you'll have some serial part and some parallel part. So, let's say I say trace forking, I have this, and I say trace joint. And this is the output, what you see above is the output you got with just this part. Okay? When I put this here, which thread do you think is going to be executing forking and join? Or which threads? Yeah.
The main thread is executing forking and join because OMP is creating two new threads. So you're going to get forking, join, and then the other two actually.
Okay. So you'll get the main thread forking and the main thread joint. Okay.
Will we get this computation necessarily?
Meaning?
Can we have the join above the two traces?
Can we have the join? Does the join have to be at the last one statement?
Because it's the main meeting.
if
Well,
you use the
actually,
executor,
yeah,
if you're waiting for the
on the last slide, you guys have waited for the thread processing.
Okay.
Although if we didn't do that,
Yeah, so is there a way to detach my threads? Not wait for it.
Okay, so that's good. These are all good questions. Okay, expressibility. Okay. So, so this is what really happened conceptually. Okay, you had thread 0, execute some statement. thread 0 then do a fork n. You create T1 to Tn threads, all of which execute the statement, and then you do a join, okay, which is this waiting, and then the execution continues. Okay. Okay, so this is just what I'm saying. Can you have a slightly more efficient thread creation mechanism given this picture?
You'll need to make one, n minus one threads, just have one execute and C0.
So that's not what OMP does, we saw. But it could just create T0, Tn minus 1. Because the main thread was doing nothing while waiting. And then it could go and wait. T0 could then do the join. Okay.
Why doesn't it allow that as an option?
The system was produced by in an undergrad thesis. Okay. Next time you do a project, I'll go and keep asking you, why didn't you do this and this and this also?
Go for it. I mean, I can see there being.
So I'll tell you what, I asked him, why don't you correct this? He said, why don't you go and change it? I'll go and tell you, why don't you go and add that option to that piece of code? Okay? It's easier to say and very much harder to do.
I don't mean practically, I mean conceptually.
Conceptually, I'm saying this is an alternative.
Right, so what I mean is whoever designed this made a choice.
What is the this you're talking about, OpenMP or that implementation?
I'm gonna say both. So
You can't say both.
the person who designed, the student who wrote this system had something in mind when they designed the system.
Yeah, like finishing in time. Okay.
So
Let's just,
I think just the handles all of them identically this way, there's otherwise you have the special case for the first one.
no, you could do it, and you're welcome to do it. I mean, I think we are just belaboring the point here. You can do the other way around. He didn't do it. End of story. So now, can you guys have used fork in operating systems? Can you see a similarity between the Unix fork and this fork? And let me show the Unix fork. Okay, so you have a statement, then you go and do a fork. What happens afterwards?
Keep running, but they're doing two separate.
So you create a new process.
There's two cases.
Okay, so you had P0, good, and it did a fork. What happened after that?
So you'll have one designated as the parent process.
So you create a new process P1.
Yes.
Do they both execute statement?
One will execute statement, the other will execute another statement within its, like, one's gonna execute the parent statement, one will execute the child statement.
Both will execute the statement. You can use the return value from the fork to split those two.
Okay. So both will execute the statement. And what you typically do is look at the ID returned by fork. And in the parent process, the ID is the child PID. In both cases, it's child PID. Okay? And the parent can go and say if the process knows it is the parent by comparing its PID with the return PID. If the get PID is not equal to child PID, then I'm the parent. Otherwise, I'm the child. Why? Yeah.
In the previous slide, why he didn't do his thread as one of the worker threads is because there needs to be a thread to wait to listen for the other threads to finish.
So that particular thread, so
So
since
that particular thread, if it switches over to doing the same task that the other thread's doing, there's now not a thread that's waiting for all of them to get done.
that thread could be given another piece of code runnable that goes and does this extra step afterwards.
Yes, but you can't all be done until that one's done, so it'll finish and then it'll wait for all the others.
We'd have to switch. So I'm just saying, like, you could do it, but I think part of the reason why you wouldn't is because there's all that.
So it's more complicated, guys, and he didn't do the more complicated thing. He hasn't done a lot of things right. Trust me on this one. So let's not get into that implementation at all. Okay. So why you didn't seem to like this?
I think it's they return zero.
They return zero.
They return zero for the parent and not zero for the child. Something like that.
No, it's zero. It's the parent. It's the child's ID to the parent and zero.
Yeah.
Oh, zero in the child.
Zero to child.
Child gets zero, parent gets child.
Okay.
I don't remember which is which. I just know one's something.
But this code will still work, right? So my semantics would also allow you to distinguish between those two things.
Maybe I just misinterpreted what
Okay. So, and then you can say joined child PID, right? So you're joining a particular PID there. And if I want to create multiple processes in Unix, what happens? Multiple child processes?
You just keep forking.
Keep forking, okay? So Pizzo will join. So here we are waiting for termination of a particular PID. If you create multiple processes, our join will change. So when you have n slaves, we'll just do a join, and we'll do a fork. We'll do a little loop there, and go and create the processes in a loop. Okay. So if you compare this with the OpenMP parallel attribute, this is procedural code. Who knows whether it's correct also or not? It probably is. But the declarative code is so much easier to convince yourself about its correctness. Okay? So fork join is an idea that is, old. It's in OpenMP, which OpenMP got invented in 1997, I believe. But Unix got invented in the 60s. So this is not entirely a new idea, but it's in the thread context and the language context. Okay, questions? Okay. Now let's go and consider. So kind of what you said initially was that they have to execute the same piece of code, right? And we're trying to classify the same kind of different kind of problems. So so we're trying to dissect the problems, and people have done it using two dimensions. Are they executing the same code, or are they accessing the same data? Different code or different data? Okay, so that's the point I want to get to, more than the producer-consumer thing. The producer-consumer thing I just gave as an example because we went and considered that, but I want to just talk about the range of problems that it can do, and what we need to do in addition to get the range extended. Okay, so here we have two threads. They're all printing random numbers, and random number generators normally use a particular seed. So they're sharing that seed, initial seed. So we have same code and same data, right? So that's what we did with the random number thing. And I can change the thing to no data, just print hello world. That's the classic example people use when they're using OpenMP. That they can, you just print a value. So we can abstract that out by saying that OpenMP, what we've studied so far, can support this class of problems. That you have the same code and same or no data. Okay? And two examples are here. In one case, I'm printing out whether a particular random number I generated when converted to an int is prime or not. And in one case, I'm printing out hello world. Okay? So see this class of problems? Now let's consider this class of problems. Same code, same or no data. How many examples can you think of? Realistic. So firstly, is this a realistic example? Is this something you want to do? Why are we printing in multiple times, right? Is this realistic? That's the most realistic example I could come up with. Okay? So even though in the taxonomy such a point exists, and in pipeline architectures, people talk about the different parts of the pipeline working on the same instruction at the same time in the same data. This is just a point in this taxonomy, and it's not a very useful point, but it's a possible point. Okay? Questions so far? Now let's go to different points, other patterns. So this is the taxonomy you come up with. SIST, SIMD, multiple instruction, same data, multiple instruction, multiple data. Okay? And now, yeah.
What about validation? That's a process, like the computation you do is correct. So sometimes in ineffective neural nets, you can produce an incorrect computation at some point, so they have to do validation checks. On the last slide, were you looking for a situation where you want to do the same computation multiple times? I'm thinking data validation.
So when I say same data, I mean same atomic piece of data. You could have different instructions when you have different code accessing different parts of an array, okay? And one thread validating one part, another thread validating another part, that's different. Also, if you want some kind of fault tolerance, that there were these tandem computers, where they were always, the same computer was always, you take a majority vote, and you say that we know that computers can fail, so we'll have them all do the same computation, and we take the majority value. Okay? This happens in a lot of safety critical applications. That would be an example too, when you don't trust the thing to be correct. But if you trust the action to be correct, then I can't think of many examples. Okay, that was the point.
Are we to say that we always trust the actions correct then in this class?
I'm qualifying it by saying that when you can do that is correct. I'm not making a judgment call of when or not.
I mean, you see what your computer is doing right now is, what the spec says it's going to do.
Right.
Okay. So I'm not making a judgment call there. That's not the point here. Okay? So we can see that SIST is straightforwardly supported using the parallel construct. Okay? So also, we won't be able to just declaratively support all cases. So I want to go and start looking at some imperative constructs also. Okay? And I want to look at the imperative construct for two reasons. First, to show you that it's expressive enough, that corner cases can be handled. Secondly, I'm going to go back again to more declarative constructs later, and I want to go and show how they are implemented using the procedural construct, imperative construct. So I want to just introduce this new dimension so I can explain a little bit formally what the other constructs do. Okay? So can you think offhand, by the way, of some very simple imperative construct that can give us a lot of flexibility? Like you were trying to make a distinction based on random numbers, okay, that we'll do one or the other action based on random number. Or I'll do one or the other action depending on which order I got something from a queue, okay? Yeah. Yeah, but what do I use in if then else? He was using random numbers as if then else.
Conditionality.
Sorry?
Conditionality.
That is what if then else is. So let me go further and point you to that. It'll be very simple. So let's go and look at this particular problem. I've got a list, and I want to sum it up, and I want to convert that into a string. Okay? So I want one thread to go and find the sum of the value, the other thread to go and create a two-string representation that I can print out. Okay? With the constructs that I have so far. Okay? Can I go and have one thread do one and the other thread do another? I need some if then else. What do you think? Because I have to start with a single piece of code. What should that if then else involve? What condition should it involve? What could it involve in this case?
I could say if thread 1
Thread 1.
Since I don't have something for thread 1 and thread 2, maybe use the thread IDs or something.
So maybe I need a thread ID motivated by Unix. Okay. So how to integrate alternation with fork join? It's motivated by Unix. So we have a get PID there. Task depends on ID. So if I say if thread is 0, do this. If thread is 1, do this. Okay. So again, it's the capacity that I have much more flexibility with this. I can create pieces of code that use random numbers or do other things. But this gives me far more control, okay, over what I want to do. Okay. So allow each member of a thread. So we have a thread sequence. We know what order number we are in that sequence. We know what order other people are. So we can use that as a discriminant. Okay. So this is the piece of code you can write. You can say if and this particular construct is a predefined thing. So whether you call it get PID or OMP4J thread num, it doesn't matter. That's just a detail, but we can do something like this. Okay. So that's the point I was getting at when you were belaboring the producer-consumer problem. I want to just get to this point. Okay. Now I can go and do producer consumers and two different producers that may be produced from two different, one producer's producing items from this array, another producer's producing items from another array, and now we get to do the capacity to have these things. Whereas you guys were coming up with producer consumer problems, they're very restricted. Okay?
So is OMP4J thread num generated, is that value generated by OMP parallel thread num 2? Or
Yeah, by the precompiler. The precompiler added this code. Precompiler, the OMP, there's a runtime also agent. There is a runtime available also. And that runtime is accessing this. Okay, yeah.
I guess my question is, do we care, right now with this paradigm that we've given thread IDs and we're choosing the code path by ID, we care what thread is doing what task, and that just seems the opposite of what I would assume, that I don't care what thread does it, I just care
Indeed.
that
So
A
we'll
does it.
I'm just going to generality.
Yeah.
We'll later get rid of this.
Oh.
Okay? I want to show you that we have the generality, and then we'll go and say we can do better than this, where we are where we don't care whether it's thread 0 or thread 1. Okay? And we'll have to wait for future classes for that. We'll run out of time. So, but just to summarize, that we have now, we have added some imperative constructs, get thread number, get num threads, to go ahead to embellish this feature. Okay? And we have much more discriminating power to do things. Okay? We don't have to write specific classes of producer-consumer problems. We can do any producer-consumer problem, producer-producer problem using this. Okay? So I'll hang around after this to answer some questions you guys have, but all the guests can leave. Okay, so different code, same data concurrency. We've managed to do that with thread number, and as we discussed last time, we'll try to get rid of that with more constructs and not have to say get thread number equals 0, thread number equals 1. Okay, but let's postpone that for a while and look at some other aspects. How about same code but different data parts? Okay, so the idea is that I want to round up an array of numbers, an array of floats, and I want two different threads to round up different parts of the array. Okay, so rather than having one thread do the whole array, I want multiple threads to round up. Okay, so we need to somehow divide the data among threads. Right? We need some way to do it. And can you guys think of a way to do it with what we have so far, the constructs we have so far? Yeah.
Just pass certain chunks of the data to one of the enumerated threads.
Okay, so we are going to process the data and send some chunks to one thread and some chunks to another thread. And what will be the basis for sending the chunks to one thread or the other? How will we do that exactly?
Depends on the size of your data set.
Right.
And
So it
then,
depends.
like using the size of your data set and how many threads you have sort of available, like if that's something that you can.
Which we know we have.
Yes, assuming like we only can do 2 more threads and we have a data set, we can divide the data set into 2 at the arbitrary middle point and then split them up.
Good. Okay, and we might not want to tie this to data as such, but we might want to tie it to a loop, so that if I'm going to so that we don't get tied to an array or a map or some other data structure. So MapReduce we look at later is tied to a map. What we'd like to do is to not tie ourselves to a particular data structure. Okay, so we're going to we want to tie it to a loop. Okay, because loop is something that you use a lot. Okay, so in that case we want to send. So we're not talking data, but we've got a loop. So given say a for loop, what will be the basis of dividing the computation among threads then? Let's say it is for I equals 1 to n do.
Send the things in the even iterator to thread 2, the odd to.
Excellent. Okay, if you have 2 threads, every odd I we send to one thread, and every even I we send to another thread. Okay, so we need a thread-aware float list round now. Okay, so far, you know, we need some some function that will do the round, and it has to be thread-aware. And what do we need besides thread ID to do the division? We need to know the index, right? So we will go and choose which indices to process based on thread number, number of threads, and loop parameters. Okay, so the loop parameters will tell you how many iterations there are, and we can go and then divide the computation based on that. So this is my single threaded round. I just have a loop that goes through a list and rounds it up, and I'm tracing it. And by the way, notice I've got small float, primitive data type float here, rather than the object type float. See that? So rather than saying capital float, I have small float. Does that make we talked about this last time, so I want to emphasize this point. So does that somehow reduce our memory requirements?
I didn't know they were separate.
Oh, there's a capital float. So what's the difference between capital float and small float? Object versus primitive. So in the array, if this is capital float, a list, what is stored in the array?
Objects of capital F float.
Robert? Pointers. So there are pointers stored, and the pointers point to float objects that are allocated from the heap. Whereas when it is small float, it is what is stored in the array? The value itself. So every time I go and do a round of a list, is there going to be some memory allocation here? If it was capital float?
Yes.
Okay. So we talked about that during the loop, we might run out of space if we have zillions of data. Okay. So there's a garbage collection issue, and that is the issue that at some point, you might want to go and listen to the talk I talked about. It's on recording also. So the parallelized version, so what we'll do is, how will we parallelize it? Here, what are the steps we need to take just before I show you the code? We'll put a parallel inside the for, outside the for. Outside, right? Good. And then what else will we do here? Based on what you said, what do I need to do? Even iterations, odd iterations, what will I do there for that?
Some sort of conditional.
So have some kind of condition inside. Where? Inside the loop. Okay. So we have some method called process iteration that says, do I process this or not? I'll give it my thread number, I'll give it the index I, I'll give it the step size, I'll give it everything, and it can decide what to do. And odd even is one way to do it, there's many other ways to do it. So we'll just make that like an interface call and have multiple implementations of it. Okay? Questions? So that's my code here. I'm again going to do 2 threads, and I can't process iteration. I pass the fact that the index I is initially the first 0, then has a step of 1, and it ends on list.length. So I'm just making it very general. And I pass my thread number, I pass the number of threads, and hopefully it'll tell me whether I should do this task or not. Okay? Questions? Okay, and this is the interface, and this is exactly the implementation that Yati said, okay? Odd and even. And they can be better implementations. And we'll at some point go in great depth as to how to divide the iterations. So this is going to be the interesting part, okay? So, but for now, we're just saying we can do it. Questions? So what if I didn't have a for loop like that? What if I went and used the same process iteration and wrote the loop like this as an infinite loop, and then I just broke out when I reached the end? Would the code still work?
won't thread event,
Sorry?
won't thread event, what the,
It will or it will not, sorry.
won't very well, but the other one won't.
It won't work very well?
I mean, if you have two threads, then one thread will end, but the other thread continues.
Oh, that's interesting. Sorry. Thank you. This should have been outside. Okay, so thank you. I'll fix that. So if I equals list dot length, very good. Break, put that in the end. Then it'll work, right?
Yeah.
Okay. So good. I never actually tested this out. So, but otherwise, the same kind of loop is being executed. And as long as process iteration is told what I is, what the initial value is, what the step size is, what the limit is, it can do the division. And it doesn't really matter whether the loop was really of that kind. Okay? We'll see later that when we get rid of, we're going to get rid of this process iteration later. Okay, and when we get rid of it, we'll have to constrain ourselves to the previous kind of loop. We won't be able to do this kind of loop. Okay, so I just want to make that point. Okay? So process iteration parameters may not be explicit parameters of the for construct. Okay, and declarative alternative will not have this property. So, okay, we have done two problems. In one problem, we did we did the same thing to different parts of the list, the round. In the other problem, we did different things to the same list. Okay? And you can imagine that we can go and combine these two problems. So I want to go and first round up the list. And then I want to go and sum up the rounded values and print the toString of the rounded values. Okay? So this is the output I'd really like. So round started, it was fractional numbers. Round ended, we've got whole numbers. The sum is 25, and the toText is a bunch of 5s concatenated together. Right? So this is what we want to do, but we want to do it in parallel. And we could do it this way. We could just compose our two solutions. So we could go and say, let's go and first do our round with two threads that I just showed you with the process iteration. And then we go and do the other task with another two threads where we go and actually sum it up or okay. And so so here is my parallel round. Here's my parallel sum and toText. I can just compose these two things together. Okay. Is there a better way, more efficient way to do this?
Have it sum while it's rounding.
Sorry? Have it sum, but I do want the sum to be of the round values.
I guess or just round it first and then sum it, but within those first two threads.
So I do want parallelism. So what you're saying is that T1 rounds up its values and sums it up too.
And then T2 will round it and sum it, and then you combine it.
Or you could have one that's doing all of the rounding, and the other will sum them and then it will print some. So one's job is to do the printing and the summing of the numbers.
So I want as much concurrency as possible. So am I getting enough concurrency with this solution? What are we saying? That you have T1 do what first? It will round up its values.
I think Jed's saying that you have them all do it. So like each one of them is rounding numbers and summing, and you just make it like an n number of threads station. But like, so I like that idea. I think that's an approach. I think this is a bit too simple.
Yeah.
The thing that is rounding it, I'm going to be rounding it sequentially, right? So I have an iterative there. Why not share that iterative among the other threads, and they can instantly start doing their jobs. Like if I'm summing it, I can start summing it as long as my iterator is less than the iterator I was sharing. So I know the rounding is ahead of me, so I can.
So somehow you want to make the other threads wait for you.
Yeah.
Okay, we need to wait. And the thing is that I don't want to change the software engineering too much. So I don't want my round to know about, I don't want my loops to get mixed together. So I don't like a solution for that reason. Okay, I want to write my round function, and in fact my round function and my sums function are already written. I've got a program that's already written. Okay, that's typically the case in the OpenMP. and I want to go and parallelize it. So I want to just add annotations, and I don't want to go in, I want separation of concerns, not just concurrency. Okay? So I don't mind it being as parallel as this, but I want to be efficient in terms of thread creation.
Why not have the same thread do it after it rounds it?
Okay. So then why not have T1 and T2? We do want them to, we do the rounding, and when the rounding finishes, you go and have them do the other two tasks. Right? So that's what I would like to do. They do this, and then they do this. Okay? So they're first, I should have probably got rid of those two lines there, but they've done one or the other. Okay? So how about I write this code here then? So let's assume that I've got this round function which doesn't have a parallel construct. The same round function as before, but it's got process iteration, but it doesn't create the parallel. It doesn't have a parallel construct, so it's not creating threads. Okay, because we're going to create the threads somewhere else. Okay, so let's assume this function exists, and now my code is that I have the two loops both be done under one parallel construct. Okay, so the parallelism starts outside. I first do round, and there's a process iteration there that goes and checks whether which thread's going to do which iteration. And then I go and say if my thread number is 0, I do sum, otherwise I do text. Okay, so to text, to sum, round are all done in different methods. Okay, we have separation of concerns. And do you guys see the problem here?
Yeah, because what if the thread hasn't finished? So say I'm thread 0 and I'm ready to sum, but thread 2 hasn't finished rounding yet.
Yeah. So the rounding is being done by two threads. One thread may be ahead of the other thread, and the sums and the so you see the output here, right? So you see that round started. One thread says round. Both says round started. One guy finishes his round, and then sums up all the values so far, and the sum is not 25, which is what we want it to be. And then the other thread ends its values, and its to text is right because all the values have been rounded. So what construct would you like to add now to allow this, to allow us to have a correct solution? I do want the efficiency of having just two threads. A wait. What would that wait be? What?
Just like basically don't go on until all the threads are finished.
So basically we want a construct. It's not the regular wait that we have. It is a wait that says wait until all my siblings have reached this state. Anybody heard of this construct anywhere? Okay. So it's called a barrier. Okay. So you just say OMP barrier. And the first time I heard of this was some work that was in the 80s. A lot of this work that I'm talking about was done in the 70s and 60s, actually, just put into OpenMP in the 90s, late 90s. Yeah.
I don't see the advantage of having two threads doing the same work. Why not just have one doing the rounding and the other one sitting behind it, just like one basically function behind it, doing the summation and the printing?
Which is faster.
How would you even do that? Because you don't control how the threads execute. Right?
They're gonna share. They share a space in memory. So almost in memory.
So hang on. What problem are you trying to solve here? Before we try to figure out your solution, what's the problem here?
The problem I see is doing the same thing twice.
Which thing? Which?
You're rounding twice.
No, you're rounding different values. You're the one who came up with the solution that one person rounds up even indices and one rounds up odd. And if we have 1 zillion of those, why not do them in parallel? And I've got separation of concerns.
My concern is you're trying, like, it's almost as if one thread is trying to do the whole thing without having the other half.
I don't know what you mean by that. Okay, we are doing the round in parallel. Now we need to go and sum and to text it. We can't start that till both threads are finished, so we wait. What's wrong with all of this? Okay, think about it offline. Okay,
This feels inefficient.
well, you can't, in a class like this, you can't use the word fields. Okay? This is not an emotional class, you know. So you have to have a concrete, heady argument. Okay, so think about it offline. Okay, let's just move on. Okay,